Okay, hello everyone. Welcome back to the second and final session on Stellarium. Um, I hope you have definitely gotten the installation done and started with the project, if not completed. At least a few sections you must have been able to do by now. What we'll do is I'll take questions and make it more interactive for this session. While I also will try to summarize each of the sections in the worksheet for your benefit, and we can discuss if you had any issues or any doubts that you might have. Okay, so you should be able to see. You can already see hands up. You should be able to see my screen. Yeah, to begin with, maybe we can, I'll just take a few general questions, not specific to any particular topic or question that is mentioned in the worksheet, but anything general about Stellarium or the activity that you would like to know. Let's start with Abhijit. Abhijit? Yeah, you have a question?
Yes, my question actually relates to how to submit that. It is written that we should submit in a group.
Yes.
But the activities there, it involves all these personal thing. You need to put the location and you need to put the date of birth. And
right. So there are some questions that it requires some personalization. Yes. So the whole idea was that while solving it, you might have these questions where you put your own information, but as a group, you would discuss as to how to go about answering the question. So the group part of the activity was discussing among yourself, because that is something common, right? How you would go about answering the questions rather than the exact answer itself. And for submission, what you could do is just pick one of the worksheets of the group members that you all agree with, that the answers are right since you work together. And you can just submit one of those.
Now, another thing, another problem that I'm facing is to actually communicate with the group members. Actually, I have put a message in the general chat, but no one has responded till date. So I'm finding it difficult to connect actually.
Are you able to connect with at least some of the members?
No, none actually. None.
Okay. So since this is related to the refresher course, which is managed through Moodle platform, which is separate from all these other participants who are also attending from the student side, what I'll do is I'll raise this up in the Moodle platform. We'll try to take a census of how many people are in groups and how many people are active, and if they have any problems with communication and so on. And then we'll try to solve that over there. Is that all right?
Okay.
But yeah, I'll get in touch with all the groups and then try to figure out what the problem is.
Okay. And right now, what I am doing is that I am finishing off my things in the assignment.
Okay, sure.
That's all I'm doing.
Right. No, eventually even the radio astronomy thing needs to be submitted in a group. So we'll try to figure this out. Try to figure out what could be the efficient way for you to work in groups.
Yes.
Sure, no problem. Thanks.
Okay.
Jyotirmay, you have a question? So I should mention that the participants of the summer school who are attending, you are not expected to submit anything in groups or individually. You can just work on the worksheets for your own interest and post any questions that you might have in that Google form. Yeah, Jyotirmay, were you able to unmute?
Yes, am I audible?
Yes, you are.
Actually, I'd like to know that question number 2.4, suppose determine a relation between the latitude of a given location on Earth
Shall we? We'll go to the questions and sections shortly. But did you have any general comment?
General comment means suppose there is an image of point 2.2. So means you have to tell that what is the exposure time for the camera to get the star appears to move the sky due to Earth rotation.
All right, I'll start with that.
Yes. If you discuss this image, that what will be the exposure time, it is not understandable to me.
Sure. What I'll do is when we reach to section 2, I'll bring it up again. And we'll try to see how many people got the answer and how many did not. Were you present during the last presentation, Jyotirmay?
Yes.
Were you present in the previous session, because we did discuss this?
Yes, I was there.
Okay, it's all right. We'll discuss it again today. Okay. Is there anything else for now?
Not anything else.
Okay. Any other general questions anybody has about Stellarium, the activity, or anything at all? Okay, if not, what we'll do is we'll start going section by section. You can have your worksheet available in parallel. Ayush, you have a question?
Hello, am I audible?
Yes, you are.
Sir, I need to know how can I connect my Stellarium with the telescope so that I could have a real-time scenario for the stars and the galaxy, and also I could record it.
I'm not sure. I know it does allow you to interface with the telescope. So you have a remote control, an automated telescope, is it?
No, sir, I do not have that.
Then what do you mean? You mean simulating a telescope observation?
Yes, sir.
Oh, okay. No, I haven't myself used that feature as yet. The best bet would be to go through the documentation. Did it help? Or just search online how one would make a...
Well, I have gone through the documentation as I have been using the Stellarium from the past 4 or 5 years.
Oh, there's nothing?
And no, so I was using it previously when I started it, then I haven't had a telescope. I was just observing the sky with the naked eye and then just catching up with the stars and the galaxies. But when I had a telescope, then I tried to configure it, but I wasn't
I'm afraid I cannot help you with this right now. But maybe in the future we'll try to figure it out and create some sort of module.
There is a way to connect the Stellarium with the telescope, right?
Now, do you mean connecting to an external real telescope, or you mean simulating an observation using Stellarium itself?
Connecting with the Stellarium with the external telescope.
I think there is. As far as I remember, there were some options where you can connect it.
Okay.
But I haven't explored it much. We'll try to see at the end if we have time. We'll see if we'll try to pose the question to everyone else and see if anyone else has worked with that. Maybe it will help. Okay, you can probably lower your hand if your question is done. Okay, if you have your worksheets ready, you'll see that the first section is just about getting familiar with the constellations, essentially. Now, you'll realize working through that particular section is that constellations do have their uses. They may not be scientifically based on scientific, some sort of scientific reasoning, but you would see that for just plain local observation purposes, it does serve a very good use. And definitely in ancient times, it was exceptionally useful for timekeeping and trying to see what is happening in the sky. So in this case, the first thing it would have helped you is identifying some of the constellations and try to realize that the background against which it forms a very effective background against which you can see various motions that exist in the solar system of the sun, the moon, the planets. You would have also seen that this is a very good static background that you have against which you can try to see various changes in the sky, at least in the time scales of 10 to 100 years or so. Beyond which, sometimes the stars themselves, the motion of the stars themselves become important, hundreds or thousands of years, and eventually even the axis of the Earth does move because of precession, and all sorts of changes can come along with that. But for tens of years, even up to 100 years, it's pretty good to consider this as a static background and try to see what all changes with respect to it. And you would have seen that it was pretty useful for planning observations. Let's say you want to go outside and actually make a naked eye observation or through a amateur telescope, then these constellations do have the purpose, do serve the purpose of trying to get to the position of the object that you're interested in pretty easily. That was I think the section ends with that particular question. Now I'll try to answer the question. Jamir, you.
Yeah, so my answer to the earlier question is, yeah, you can interface with the Stellarium, like some telescope and the drivers they allow. And as well as even the Arduino, you can interface with the Stellarium software and you can make your own go-to telescope or the tracking telescope.
Arduino, you mean that you can install Stellarium there and use it? Is that what you mean?
No, actually, you can connect your Arduino to the telescope, and you can these two software can talk interchange. Or there are some drivers. With the help of that, you can do that.
Oh, I see. Okay.
Okay. So once you connect your Arduino to the your system and you install Stellarium in your system, then it should. So there are like few programs you need to install and few drivers you need to install.
Is there Jimmy, do you know any good online resource where this information is available?
GitHub is one what I have earlier seen. I guess you can find on GitHub, or maybe I will search and I will put somewhere and we can share with these people.
Yeah, you can let me know. I can.
Yeah, sure.
Sheet. Thanks.
Yeah, welcome.
Sabita, you have a question? So now, anyone who had any trouble with section 1, any part of section 1, you can raise your hand and let me know. We'll try to figure out.
Hello, am I audible?
Yes, you are. Go ahead.
So actually, I'm completely new to this Stellarium part.
Right.
So I am facing problem for part 1.6 and 1.7. Actually, I am using a ecliptic line and
which line?
Ecliptic line, the path of the star.
Okay.
To calculate, but actually I cannot realize how to get it because everything on the sky is moving, and with respect to what I can consider, it gives me just some hour or minute like this, which I am thinking it's not a correct answer.
I'll do a small demo.
Yeah, thank you.
Sure. You said 1.6, and in this question, we are trying to find out how long does, let's say, the sun or the moon takes to go across a particular constellation, right?
Yes.
So to better see this. Sorry, I just got disconnected there. Yeah, my Wi-Fi sometimes gives problem with Zoom where it suddenly just breaks the connection. Sorry about that. If it repeats again, I think I'll try to connect it with my other data connection, and we'll try to see if it works. For now, you guys can hear me fine, right?
Yes.
Okay. So I'll start sharing the screen again. Okay, so we are here. We have to turn up the atmosphere if we want to see the sun along with the background stars. And what you would need to do is, let's say we just work with the constellation that it is currently in. It seems to be Taurus. And a useful option to turn on would be the boundaries of the constellation so that you know when it enters and when it exits. So there is an option under sky. What is this? There is a viewing option under star log. Here you would see it says show boundaries. So if you turn it on, there would be this faint red color boundary that would show up around the constellation. So, I mean, this question need to be answered only approximately. You don't have it very exact to the minute or seconds or anything like that. If you can find out the approximate number of days that it takes to pass a particular constellation, that would be good enough. So right now you can see it's on Taurus. To keep the point of view focused at a particular object that you're interested in and keep it centered all the time, you'll have to select center on object option. If you see from the bottom panel, there is this, if you can see my cursor pointing towards it. So that is the center on selected object. If you keep that, the object will always be centered over here, right? Now, after that, what you can do is just use the time option. So you have this date and time option, and you can go up or down in day, for instance, in the case of the sun. So it's 24th today. And if you see 25th, I changed 25th, there was a jump. And if you see, as long as the object is centered on it, you'll see that you have no trouble seeing the object move, in this case, the sun, towards the boundary. Similarly, you can go back in time. I'm right now just using the arrow keys up and down. So you can start from somewhere like this. Let's say it's 14th of May, it entered Taurus, and it continues on from the 14th all the way till approximately 21st.
Okay.
So
okay, I got
about
it.
7 days, right?
Okay, got it. Thank you. Yeah.
Sure. So you had a problem with, okay, the other one is also 1.7 is the same thing, except you'll have to look at other objects, right? So, okay.
Yeah. Yes. Planets and okay, thank you.
Abhijit, you have a question?
Yes, I have a question with 1.8 is Barnard star proper motion.
Right.
Now, what I have, I looked at the Barnard star and I changed the, years in increments. So, my question is that whether we should keep the field of view constant while we do this, because at 60, which is the default thing.
Right.
Then say around in increments of 10 years or so, I could see some changes. But if I zoom in, say making the field of view small, say 10 degree or even less, then even with a change in increments of by 1 year, shows some movement.
Are you sure it's with respect to the background of stars?
Yes, because when you zoom in, we actually see more clearly.
You mean zoom in too much? No, you'll have to select a field of view that is, somewhat closer to how you're observing the sky. rather than going very close.
That's what actually what I did. I zoomed in, a lot, so that the nearby stars are very clearly seen, well separated. And then when I actually gave the increment of 1 year, even with 1 year, I could see some movement.
Okay, but I do think it's still odd that you would see in 1 year. Okay, maybe if you zoom in quite a lot, then you are in the arcsecond regime where you're seeing the motion. That could happen. Yeah, for this I would say that keep it at the default field of view and try to specifically see with respect to these stars rather than anything else. Even some of the lines, if you had, let's say, a grid, the grid would move because the RAN definition, which is according to celestial pole, that keeps on changing. So it gives a false impression of motion. But it's important to track it with respect to the background of stars.
Yes. That false impression is more when the field of view is large, actually.
Right. It could be. Yeah, it will be. Yes. Good point. So that is something to keep in mind. Make sure your field of view is the default, let's say 60 or more. And then you make sure the star is actually moving with respect to the background of other stars.
Yeah.
Thanks, Abhijit. Jyotirmay?
Yes, means my comment is for this question number 1.8. So it took some around 10,000 years to cross Hercules constellation. So that means you have to change in the step of some 100 years.
It may not be 10,000, even some hundreds of years, I think.
So that means you have to increase like 500, 600, like that means in years.
Yes,
right?
yes. So
in
what you can do is
you have to change. In 1 year, you cannot see any change with the location of the star.
Right.
So it should take minimum 100 years or 500 years. Then
so what you can do is you can go to this number here and, add 1. Change it to 2.
Yes, like 1,000, then 1,500. Like that I did.
Right.
Or 500, 1,000, 1,500, 2,000.
Yeah, like you can try those too. And for some numbers it will be more. I mean, for larger numbers it will be more visible. But you can try to see approximately for what number it would be appreciably seen even with, let's say, a small telescope. Okay. Any other questions? So I hope the first section was pretty much straightforward for all of you. Can I get a raise of hands as to how many people actually finished the section 1? Just for an idea. It's fine if you did not and you're planning to get to it later. It's completely all right. Wait a few more seconds. Keep your hands raised. So only about a fraction of you. Okay. But I hope there was no problem setting things up. It's just you didn't get around to it because of lack of time or some other reason. Okay. You can all put your hands down. Okay, we'll go to the section 2 now. So section 2 is about motions and direction in the sky. It's a short section where you learn that, how the stars move in the time scale of a day. Move in the sense not actually, but how it's apparently moving in the sky. Abhijit, do you have a question?
Yes, my question is with 2.1, the circumpolar constellations.
Right.
So, will you call a constellation circumpolar if it doesn't set, if the entire constellation doesn't set or partially it doesn't set?
If you were to go strictly, I think it has to be the entire constellation or all the stars that form part of the constellation, not necessarily the constellation arc, but the main stars that connect through the lines forming the constellation. If those stars do not set, none of those stars.
Actually, if that is the case, then there is only one constellation. But if a partial thing is allowed, then a few more comes in.
Right, that's true. I mean, we are at low latitudes, so that is bound to happen. That the north celestial pole point is closer to the horizon, which means there are going to be much fewer constellations that are circumpolar. Yes. That is expected, but you're on the right track. Jamil? Yeah.
I guess it just with the stars, and the stars which doesn't set or doesn't rise, we call them as a circumpolar star. Like it's nothing to do with the constellation.
No, you can define them for the constellations too. I mean, okay. It's an informal thing. It's not necessarily anything scientific there. But just as you define the circumpolar stars, you can always say circumpolar constellations.
Mm-hmm.
And you just follow the same logic there. Jyotirmay, you had a follow-up? Any question?
Sorry.
Jamil, you want to add something? Jyotirmay, I cannot hear you guys.
With respect to 2.1 section, you're asking?
No, your hand is raised. That's why I'm asking.
Oh, no. Just, I will lower it. Just a second.
Okay, considering even Jyotirmay does not have a question. Okay, so you would have seen how the apparent motion of the stars are during the course of a particular day, which is entirely due to the rotation of the Earth. And the section also introduces you to cardinal points and the point zenith, which together can be used to define a local alt-azimuth system, where you can define a position of a particular object using these two coordinates: the altitude, which is the direct height above the horizon of the particular object, and the azimuth, which is defined according to the direction north, going eastward. That is the alt-azimuth coordinate system, which changes according to where you are on Earth. So it applies only locally at any location. Okay, I hope the second section, did any of you have any doubts or questions about how to go about? Okay, so there was this thing about question 2.2, right? So who was asking the question initially? Can I get that person to raise their hands again? I forgot the name. Was it you, Jyotirmay?
Yes.
Yeah. So you had problem with 2.2?
Yes.
What exactly was the problem?
So this question means what is the exposure time of the camera?
Right.
The stars appears to move in the sky.
Right.
Means for this picture, I am seeing that means it is like 1/4 quarter rotation. So
yes.
Means 6 hours will be the answer.
Yes, you're right. It's closer to 6 hours.
But quarter means by guessing, like this one bright, this circle is 1 quarter or means half quarter. Okay.
Yeah, the question doesn't expect you to come up with a very precise number. It just it just makes you realize that, it uses the fact that the daily motion is due to the rotation of the Earth, from which we expect that in approximately 24 hours, a particular star is going to start from an initial location, go around the celestial pole, and then come back to its original position in slightly less than 24 hours, but very close to 24 hours. From which you can deduce, seeing a photograph of such sort with star trails, as to how long the exposure it can be. So it's just that. But you're not expected to come up with anything very accurate in terms of minutes or so. All right. Okay, I hope this is clear to everyone else as well. Let's see, any other questions in this section? Okay.
Yes.
Jyotirma, you have your hand raised again. You have a question?
Am I audible?
Yes.
So question number 2.4.
Yes.
There will be a
Yeah.
relation between the latitude of a given location on Earth
Yeah.
and the altitude of the celestial pole point of that location.
Right.
It is like that means altitude of a celestial pole point location will be 90 degree minus the latitude or equal to latitude.
How do you think you can figure this out?
Means suppose I am in northern hemisphere, then what will be that?
Let's make it even simpler. Let's say you're on the North Pole. What would be the altitude of the pole star?
90 degree.
Right. So, and what will be your latitude?
90 degree.
And so you can see that it will be the same for the South Celestial Pole too. Let's say you're at the equator now. What will be your latitude?
0.
Right. And where will the pole star be if visible? Where do you expect the pole star to be if you're standing at the equator?
90 degree.
Sorry, I didn't hear you.
90 degree.
No, where do you expect to? So you, when you were at the pole, you saw it overhead, right? Directly
Yes.
overhead.
Yes.
Now you move on to the equator. Where would you see the pole?
I can't see, means it is the horizon.
Yes, it will be at the horizon.
Yes.
So horizon, the altitude would be?
0 degree.
Yes, and what was your latitude?
0 degree.
Yes.
So
Now,
both
I mean,
are
these
equal.
two are the extreme cases. Similarly, you can do that at your location where you're observing from. You can Google what the latitude of that location is, or I mean, the Stellarium does show it if you click on the location field. And you can check what the altitude is by either turning on the grid, the altizimuth grid, and seeing what the height of Polaris is, or you can select it and it'll show you what the altitude of Polaris is. And if you fill that out, it will be all clear to you. Is it clear now?
Yes, thank you. Yeah.
Sure. Okay, so I think that done. Sorry, guys. I think I'm having some trouble again with the internet. Switch the connection. So hopefully it will be stable till the end of the session. You guys can hear me fine? Santosh, do you hear me fine? Okay. At least I got a message saying that it's fine. Let me share the screen again. All right. So I was talking about timekeeping using the sky section. And so you would have learned about, or some of you will learn about the meridian and equator, which is used to more precisely chart out the motion of the stars in the sky during the course of the day. This actually helps in celestial timekeeping, which is what we adopt for, approximately what we adopt for timekeeping on Earth. We follow the motion of the sun and try to define the time according to that. How it reaches the highest point in the sky during the day, we call it as local noon. And this, identifying the equator and the pole points essentially allows you to recognize an absolute coordinate system, which is the equatorial coordinate system with the right ascension and declination. So let's see, in section 3, anybody had any doubts? Did you guys try? So there is a question in the chat. If I have any query related to the assignment or any other issues with study, where can I put my query? If you are in our refresher course, then you should post it in the forum, the Moodle platform forum, the course forum. But if you are a student part of the summer school, then I suggest that you use the Google form that was supplied. Either you can look it against my presentation schedule in the first week, or maybe they'll add another link for today's session as well. The same, it should be the same link. As long as you raise a question there, I'll try to get back to you with the answer. Okay, Abhijit.
Okay, it is not really a question, but in 3.3.2, question number 2.
Right.
Search for the planets Mars, Venus, Jupiter, Saturn. And next, how close or far from the ecliptic do these planets lie? So how to answer that actually? By giving the angles, angular separation?
Yeah, approximately you can say it lies within these many degrees from the ecliptic.
Okay.
For that, the one thing you could do is turn on the one of the coordinate grids, and that will help you decide how close they are. It doesn't have to be exact answer, but if you say, let's say it's 1 degree within the ecliptic line, or 2 degrees, or 3 degrees, 1.5 degrees, whatever, that you find, that would be good. Is that clear?
Okay, thank you.
Sure. Okay, any other questions? So this is answering a question from the chat about whether summer school students need to submit an assignment. They don't. You have any questions, you can raise it using the Google form that will be linked in the PPWorks page. But other than that, you don't have to submit any finished assignment. But I do suggest that you do it, especially if this is the first time you're encountering software and haven't worked with it. You'll find that it's quite rewarding and interesting to work with it. So
Prakash, you are not audible. I guess so.
Extremely sorry, guys.
Yeah.
I'm having a lot of problems today, I guess. Usually it doesn't break so many times in a session. Okay. Did anyone else have any questions regarding section 3? All right. If not, we'll go to section 4. Section 4 is very general. It's general sky observations. I mean, two sort of minor thing it goes over. One is it simulates the idea of apparent and relative brightness of stars that you can apply by turning on the light pollution in the sky and trying to see which stars appear brighter with respect to each other, and how you can then try to see the actual brightness of the stars using the magnitude, and you'll get an idea of why some of the stars do appear to be brighter, but they are not. And it'll use the magnitude formulas that you learned in introductory courses, and you can try to figure out which stars appear the brightest in the sky, and versus which stars are actually the brightest in the sky. Okay, I see a raised hand. Deepa, you want to ask a question? I cannot hear you. Yeah.
Section 3.4, the ordinal point 0, 0. So, my question, convert the following from wiki. Note down the RA and
Can you repeat your question? Your voice was breaking for me.
Hello, sir. Can you hear me?
Yes.
My question is from the section 3.4.
Yeah.
Second question, note down the right ascension and declination for the flowing objects for the flowing times.
Right.
How to answer that question? How to find the declination and right ascension?
So you just need to select the object. Just like, let's say, okay, I'll share the screen. Okay. Let me share the screen and show you.
Okay.
Yeah, do you see Stellarium?
Yes.
Okay. So once you select any object, you'll see there's a display that shows up in the left-hand top corner, and it has a whole bunch of information about the system you're selecting. And there you would see RA, deck, altitude azimuth, and all this information. So you just need to do simply that. Except you have to go to the specific date of a particular year. It could be any year. I mean, around the time you observe, around the current year, and then you can note down the readings.
Okay, sir.
It just will give you an idea of what things change and what things do not change over the course of a year, and it should be consistent with the picture that you have by now, by the end of that section, as to why the changes that you see in the sky happen. Okay?
Okay, sir. Thank you.
There's a question in the chat about whether the students will get a look at the assignment for practice. It has already been posted in that EB Works platform. So there is a page called Stellarium, I think, Stellarium Worksheet, and there is a link that will take you to a place where you can download it. Okay, Prasanjit, you have a question?
Yes, sir. I have a doubt regarding the question 4.2.4.
2.4, yes.
What is the approximate inclination of the plane of the solar system with respect to the plane of the galaxy? How can we calculate it?
So, so by this question, you would have understood that there is a galactic coordinate system and you were able to turn it on, right?
Yes.
Yeah. So you have for this question, you should keep only the galactic coordinate system on the grid, and then for the path of this, we are interested in the plane of the solar system, right? Do you know which line corresponds to the plane of the solar system in the sky?
Yes.
Which one is it? Do you know the name of it? No? Hello, do you hear me? It is the ecliptic. So in the previous questions, when you worked and tried to see what the path of the sun follows in the sky, that we define as ecliptic. And then you also realize that all the planets also move pretty much very close to that particular line. And then if you can, visualize the 3D representation of our solar system and how the Earth is inclined with respect to it, you'll realize that it's the ecliptic plane, which since we are in the plane and observing the ecliptic plane, it is essentially a line or a very thin or a slightly thick line on the sky, and that is the plane of the solar system. So once you have these, and this can be turned on using the ecliptic line, and now you have the galactic grid and the ecliptic line, and you're trying to see on the grid there will be markings. You can turn on the markings which say how many degrees each of the latitude or the galactic longitude corresponds to, and you can see where the ecliptic line go through this grid, and you can see by how much, what is the maximum deviation with respect to the galactic plane that this ecliptic line goes, and that is it. So does that make sense?
Yes, sir. Yes, sir.
Okay. Sure. Deepa, do you have a follow-up question?
Yes, sir.
Yeah, go ahead.
Sir, in 4.3.1, in section 4.3, first question, how will we find how many more months will Saturn be over in the night sky after seeing?
So do you understand why it would go out of view? So in the previous questions, you must have seen that, let's say in the first section, I think, you tried to, or I think the first or second question, section, you would have seen how some of the objects or constellations are observed only in the summer months and some only in the winter months.
Yes, sir.
Right? It's just the fact that when we say observed in these months, we just mean that in the night sky, because we can observe these stars and constellations only, with the naked eye, only in the night sky, which means that it's all due to the motion of the Earth around the sun, right? This is why the times are all different. And here it is asking about Saturn, and Saturn right now is visible, current year, current month. So all you have to do is change the date, keeping Saturn at your, have the field of view center on this object, Saturn in this case, and then change the days or month or eventually months. And then you will see that at some point, let's say, and you'll have to select a time period which is, ideally an observation period, which is, let's say, night 8 p.m. to early morning, let's say 2 a.m. or 3 a.m. or something like that. And you'll see that at some point for some particular month in the winter or next year, you'll see that it will set before 8 p.m. In which case you won't be able to see it anymore. Does that make sense? Does that make sense?
Yes.
Okay. Sabita?
Okay.
Hello.
Yeah.
Sir, I have one question. When we change the time and date from the left side panel, and also we can change it from the bottom panel, the timing. So what is
this is the progression of time. Go on.
So I would like to know the difference actually, which one we should follow, this the bottom one.
Okay. Right. No, this is for abrupt jumps. So what I'll do is you can change the date and time to any number, any valid number, and it will take you directly there. And in the bottom is essentially the progression of time. So right now it's running at 1 second per second. But if you do the fast forward, it will run faster. So right now it's running about 10 minutes per second, 10 minutes per second. And you can go faster and faster, and you'll see the changes. Similarly, you can go backwards. This is quite useful when you're in, especially the first few sections, where you're, let's say, trying to see how the sun moves across the sky. Let me maybe show it to you.
Prakash,
Yeah.
can I make a comment here?
Sure.
Yeah, to the earlier question, like it's another simple logic is that you have to note down the what is the RA of the planet, whether you take Jupiter or Saturn, and you can see where Sun is. Okay, and around 15 degree before or later, so you won't be able to see the planet because of this ambient light. So suppose the sunset is around 6:30 and the RA, the sun of the RA is say suppose 0, and maybe if the Saturn is at 23 hours or maybe 1 hour, at that time it's very difficult to see because of the ambient light which is there. So that is another simple logic when we can't see the planets.
That's right. So thanks, Jimmy. So yeah, so I mean, since the problem with viewing these objects is the sun, one can essentially try to see the sun and how, when these planets get close to the sun, and then figure out from there too, or more precisely using this RA index.
I hope this is like a bit useful.
Sabita, you have a follow-up question?
No, thank you.
Okay. Yeah, I was just going to show something, right? Just how the days progress. So we are looking at the west. So as you can see, if you increase the rate at which time moves, then you're better able to see how all the the stars, if you want to see the stars, let's say you switch off the atmosphere, you'll see that during the course of the day, for instance, it's moving only tens of minutes per second or something like that. So you turn on the equatorial grid, and you'll see how the motions are. So this is useful for essentially that. And if you get to one of these buttons takes you back to the current time whenever you stray too much past it, and you can go to the regular motion or regular progression of time using this play button. Deepa, you have a follow-up?
Sir?
Hello. Yeah.
Hello, sir?
Yes, your voice is breaking for me, but go ahead.
Hello, sir?
Yeah, go ahead. Deepa,
Hello,
go ahead with your question.
Can
Yes.
you hear me, sir?
Can you say that again?
Hello, sir?
Yes, go ahead. Say that again.
Hello, sir?
Deepa, maybe you can write your question in the chat box because you are not audible.
Yeah, your voice is breaking. So can you type it in the chat? there's a question in the chat about whether we can change the Stellarium's viewpoint to something other than Earth. As far as I know, it doesn't allow that. Unless I'm not aware of a new feature, it does not. So anyone else has any question while we wait for the archetypal question? Okay, so section 4 is the last of them. So other than learning about the brightnesses a bit, you'll see the Milky Way galaxy, and it will introduce you to the galactic coordinate system, which is quite useful generally for surveys, and it's used quite often in scientific literature. It's good to know where things stand with respect to the galaxy as a whole, rather than just the solar system. The last part of this section would be just casual observations of deep sky objects. It has this cool feature where we can see deep sky objects by turning on the option over here. Here, the shortcut is D. On the bottom panel, there's a selection for deep sky objects. It has a whole bunch of objects that are quite often visible with a small or medium-sized telescopes. And essentially, the last question will take you through some of these objects and ask you to zoom in. And what they have done is they have taken pictures from Hubble and some other composite pictures taken from observatories across the world. And they have, put it here so that one gets an idea of how it looks if it were to be observed using a telescope, essentially. The only thing, especially for people who haven't looked through a medium telescope at any of these objects, you'll see that the real object is not going to look as spectacular as some of these objects over here are shown. That's mainly because our eye is not sensitive enough, and these images are all false color, taken at multiple bands, and then put together to look so amazing. But for instance, let's see, even Orion Nebula. Yeah, when you actually look through the eyes, the pinks and the reds may not be as prominent, for instance. Similarly, I remember observing the Ring Nebula once. It looks amazingly beautiful when you look through, let's say, a Hubble image of the Ring Nebula. But yeah, but if you actually try to see it through even a medium-sized telescope, like an 8 or 10-inch, you'll see that it's fainter. It's pretty much looks sort of whitish. You cannot make out any of these colors that it shows over here. But it's still impressive because you're seeing this light live. That it can be somewhat underwhelming. Sabita, you have a question? Oh, let me unmute you.
Hello.
Yeah.
I have another question regarding direction. So always we need to change manually towards which direction we face, or is there any option available where Stellarium can direct us there?
You'll have to do it manually using the mouse. Actually, maybe there's that I don't know of. There might be shortcuts that I'm not aware of. But it shouldn't be too hard, I think. Only some of the questions require you to specifically pick a direction and do it. But make sure the cardinal points are switched, on, toggled on, so that it's easier to maneuver. But other than that, manually, we'll have to do.
Okay, thank you.
Ayush, you have a question?
Hello, am I audible?
Yes, you are.
So, it is related to the meteorites. In the past few months, I have observed different kinds of meteorites. I mean, the color of meteorites were different. Some were green and steady, and one was bluish with a bright color, and there was a yellowish. So, can you tell me more about these things? Like, what does it make the color of these meteorites?
So you're talking about actual physical stones that you saw?
Yeah.
I guess he's talking about the meteors or meteorite.
No, meteorites is fine. I was just wondering whether he's talking about how
I
it's
saw
observed
them in the five colors, so I was wondering what makes these kinds of the color changes.
I mean, it has to do, obviously, as you could also guess, with the composition of it. I mean, there are various metals. Usually, these meteorites contain metals. That's why they are able to survive. These meteorites tend to have a metallic core, most of them, and the outer regions, even if they can burn while coming to the atmosphere, the center core can survive in many cases if it's big enough. And the colors are just because some of them are oxidized. The actual color of which corresponds to which, I may not be able to tell you. But it's essentially these metals undergoing oxidation or converting due to reaction with other elements, forming some sort of compound.
Are these actually meteorite rocks from different asteroids or different planes, or is it the space debris from different satellites?
Where did you observe these?
Jaipur.
Excuse me. Oh, you mean you saw it on the ground, or?
No, I haven't saw it on the ground. I saw it in the sky. It fell upon the hills nearby.
Oh. But how are you sure that the ones that you saw were meteorites? Are you not sure?
I'm not that sure because only one of them was steady for 5 to 6 seconds, and other were disappeared within 1 to 2 seconds.
Well, that's the thing. Many of the things that you see streaking through the sky, they probably just burn out in the atmosphere. You don't actually see an object that will fall on the ground. There are a few of them that might fall, but it might be impossible to just track just by seeing the meteor showers. I think it's almost
Are these the satellite debris or actually the rocks?
No, I think it has to be meteorites. That is the rocks from space. Satellite debris, I don't know how often these satellites are deorbited, but I don't think it would be as often. Or even if they are deorbited, it will be more controlled so that it falls in the oceans or something like that.
Okay. Thank you.
Sure. Okay, any other question? We have come to the end of this worksheet. For people who haven't tried many of these sections, I strongly urge that you get started. I think you will enjoy it. Yeah, Ayush, you have a question?
Yes, sir.
Okay, sure. Anyone else has any questions? Okay, if not, we'll end it here. You can always, get in touch with me through the Google form if you are in the summer school, or through the forum, Moodle forum, if you are in the refresher course. I think I've answered everything in the chat as well. Okay. Okay, if that is all, thank you everyone for joining. Hope you had fun, the people who tried it. Enjoy the rest of the course. Bye. Santosh, you can turn off the stream. Santosh, can you hear me?